16, 17, and 18, again, we're finding the limit by using limit laws. Again, on this one, if I try to evaluate this one directly, I would have 2 minus the square root of 1 plus 3, and then I have 1 minus 1 on the bottom. Well, 1 plus 3 is 4. The square root of 4 is 2. 2 minus 2 is 0. 1 minus 1 is 0. So again, these ones are going to be cases where you have 0 over 0. And if you get 0 over 0, you have to try to rewrite your expression in a different form. So on these ones, in order to rewrite them in a different form, these are ones where you're going to have a binomial, either numerator or denominator, and you're going to multiply by the conjugate, which is going to be really fun. So, if I have 2 minus the square root of x plus 3 over x minus 1, I'm going to multiply by 2 plus the square root of x plus 3. So, I'm just going to worry about foiling out the top part. So, 2 times 2 is 4. Then I'm going to get 2 plus 2 square root of x plus 3. And then in the inside, I'm going to get minus 2 square root of x plus 3. Purpose of multiplying by the conjugate, getting those opposite middle terms so that they cancel out. Then, negative times a positive is a negative. And when I square this, I'm going to have the square root of x plus 3 squared, because I had that times itself, right? Square root of x plus 3 times the square root of x plus 3. Well, when I square that square root, it cancels out. So this is going to just be x plus 3. It's just like when you take the square root of 3 and you square it, you get the square root of 9, which ends up just being the 3. You just get the same thing underneath. So if I take one square root times itself, squaring the square root cancels that out. You just get the x plus 3. I do need the parentheses because there's a minus sign in front of that, and I have to use my distributive property. So I'm going to get 4 minus x minus 3, which gives me negative x plus 1 on top. Now if I notice here, I have x minus 1. So in order to cancel that out, I could factor out a negative 1. So I'm going to have a negative 1 times negative x plus 1. And then I'm going to have my 2 plus the square root of x plus 3. Lovely. So here I'm going to be able to cancel this with this, putting a 1 on top. So I have 1 over negative 1 times 2 plus the square root of x plus 3. Now I have my expression in a simpler form. I can try to evaluate it directly or see if I have to continue trying to simplify that. So if I try to evaluate it directly, I'm going to put a 1 in for my x. So I'm going to have 1 on top, negative 1 times 2 plus the square root of 1 plus 3 is 4. The square root of 4 is 2. 2 plus 2 is 4. Negative 1 times 4 gives me negative 4. So I have 1 over negative 4, or negative 1/4. So the limit as x approaches 1 is going to be negative 1/4. So when I have a binomial in the numerator or the denominator, if I multiply by the conjugate, it's going to simplify my expression on the top. I would wait to FOIL out the bottom to see, because normally there's going to be something that's going to cancel out. So I wouldn't even FOIL out the other part until I've gotten done simplifying this part, which is what I did here. And then I looked and said, oh, I'm going to be able to cancel that out if I factor out my negative 1. And then, again, I'm probably not going to simplify much. I'm just going to plug my number in and say, okay, now does it work out where I get an answer instead of getting something like 0 over 0, which I did, negative 1/4. Number 17, same kind of thing. If I put my 3 in, I would have 3 minus 3 on top, which is 0. Here I would have 3 plus 1, which is 4. The square root of 4 is 2, and 2 minus 2 is 0. So again, I get 0 over 0. And so even though I try to evaluate it directly, I can't. And so I have to come up with some other method. So whenever I get that 0 over 0 when I plug my number in, I have to look at it and say, oh, okay, here's another one. I have a binomial on the bottom. Let's see if I can get rid of that. So x minus 3 on top. If I can get my board to work. On the bottom, I have 2 minus the square root of x plus 1. So I'm going to multiply by 2 plus the square root of x plus 1. And again, on the top part, I'm just going to leave that alone. So I'm going to have the x minus 3, and then I'm going to have 2 plus the square root of x plus 1. And I'm just going to FOIL out the bottom where I'm multiplying by my conjugate. 2 times 2 is 4. I'm going to get 2 plus 2 times the square root of x plus 1. Then I'm going to get minus 2 times the square root of x plus 1. Those are going to cancel. Here, a negative times a positive is a negative. And then when I take the square root of x plus 1 times the square root of x plus 1, that's squaring that. So I'm just going to get the x plus 1 that's underneath my square root. So I'm going to have 4 minus x minus 1, which would be negative x plus 3. Again, you can see here that if I factor out my negative 1, I'm going to be able to cancel. So I'm going to make it negative 1 times negative x plus 3 times 2 plus the square root of x plus 1 over negative x plus 3. I can then cancel this out of there. So I'm just going to have negative 1 times 2 plus the square root of x plus 1. I've got that simplified as much as I can. I'm now going to evaluate it as x approaches 3. So I'm going to put 3 in for my x. Negative 1 times 2 plus the square root of 4. Square root of 4 is 2. 2 plus 2 is 4. Negative 1 times 4 gives me the limit of negative 4. So as x approaches 3, my expression is going to approach a limit of negative 4. All right, number 18, we want to find the limit as x approaches 1. So if I evaluate it directly, I would have 1 over 3 minus 1 minus a half over 1 minus 1. Well, here, 3 minus 1 would be 2. 1 half minus 1 half is going to give me 0. 1 minus 1 is also 0. So I have one of those where I have 0 over 0. I need to simplify my fraction then in order to put it in a different form so that I can evaluate it directly. So if I have 1 over 3 minus y minus 1 half over y minus 1. Here I have a complex fraction, a fraction within a fraction. I want to simplify that, so I'm going to multiply every term by my common denominator. So I'm going to multiply by 2 and 3 minus y. Here I'm going to multiply by 2 and 3 minus y. Down here I'm going to multiply by 2 and 3 minus y. So here the 3 minus y cancels out. 2 times 1 is 2. Here the 2's cancel out. Negative 1 times 3 would be minus 3. Negative times a negative is going to be a positive y. So on the top I'm going to have y minus 3. Nope, not y minus 3. I'm going to have y minus 1. Y and 2 minus 3 would be minus 1. So I have y minus 1 on the top. On the bottom I have y minus 1 times 2 times 3 minus y. So here I have a y minus 1 that I can cancel out. That makes that 1. So I have 1 over 2 times 3 minus y. I could use my distributive property and multiply that out if I want, really not necessary. I've got my fraction in a simpler form, so now I can go ahead and evaluate it directly. So I'm going to put 1 in, and so I'm going to say 1 over 2 times 3 minus 1, give me 1 over 2 times 2, which gives me 1/4. And so 1/4 should be my answer. I notice there's a typo here. This really should say as y approaches 1, not x approaches 1. I'll fix that on your sheets. So, again, 17, 18, and 19, or 16, 17, and 18 are ones where if I try to evaluate it directly, I'm going to get 0 over 0. And so I have to find a way to simplify my fraction. If I have a binomial, can I multiply by the conjugate? If I have a complex fraction, can I multiply by the common denominator and get rid of the fractions? And so we had the ones before where we had quadratic expressions that we could then factor out and cancel. Same kind of thing's going to happen here. I want to try to get something in my fraction where I can do some canceling and make my fraction a little bit more reasonable so that when I try to evaluate it directly, I don't get 0 over 0.